A critical software update rolls out, but a seemingly minor change unexpectedly crashes the production environment, causing widespread service disruption. The CI/CD pipeline, designed to prevent such failures, had greenlit the build. This scenario is a common frustration, highlighting that simply having CI/CD is insufficient. Continuous integration and continuous delivery or deployment automate the software release process. Code changes are frequently merged into a central repository, where automated builds and tests are executed. Upon successful completion, these changes are then prepared for or automatically deployed to production environments. This streamlined approach aims to accelerate development cycles and reduce manual errors. However, the reality for many organizations involves pipelines plagued by intermittent failures, slow execution, and security vulnerabilities, undermining the very benefits CI/CD promises. While the foundational principles of CI/CD are widely understood, 5 critical, often overlooked aspects dictate the true reliability, efficiency, and security of these systems. Ignoring these elements transforms CI/CD from an accelerator into a bottleneck, leading to developer frustration and costly delays. Mastering them is essential for robust, high-performing software delivery. The first unaddressed challenge is the silent erosion of trust caused by flaky tests. These are tests that yield different results for the same code and configuration, passing sometimes and failing others without any discernible change. This inconsistency frequently stems from race conditions, improper test isolation, or reliance on external, unstable services. When developers encounter intermittent failures, they often rerun the tests, or, worse, dismiss them as unreliable. This behavior progressively undermines confidence in the entire automated testing suite. The immediate consequence is increased manual oversight, with teams spending unproductive hours debugging non-existent issues or manually verifying code changes that should have been validated automatically. A pipeline choked by flaky tests loses its primary value proposition, providing rapid, trustworthy feedback. To mitigate this, tests must be deterministic, isolated from side effects, and capable of operating independently. Techniques include using mock objects for external dependencies, implementing retry mechanisms with cautious thresholds, and ensuring comprehensive teardown and setup for each test run. Identifying these tests early, often through dedicated pipeline stages that flag or quarantine them, is crucial. The second significant impediment is monolithic pipeline paralysis. Many organizations start with a single, massive pipeline responsible for every step from compilation to deployment across all environments. This design choice often appears simpler initially, but quickly introduces significant friction. Every small code change triggers a full, lengthy execution of this colossal pipeline, creating extended feedback loops. Developers wait disproportionately long for build results, diminishing their productivity and motivation. This monolithic structure often becomes a bottleneck, particularly in growing teams or complex microservice architectures. Debugging failures within such a sprawling pipeline is inherently difficult, as pinpointing the exact failure point requires sifting through vast logs. The solution involves modularizing pipelines, breaking them into smaller, more focused stages or even entirely separate pipelines for distinct services or deployment targets. Implementing parallel execution for independent tasks and judiciously using build caching mechanisms for unchanging dependencies can dramatically reduce execution times. This approach shifts from a single linear process to a directed acyclic graph, optimizing resource utilization and feedback speed. The third overlooked secret concerns the silent threat of unmanaged third-party dependencies. Modern applications are rarely built from scratch. They integrate numerous open-source libraries and frameworks. While these dependencies accelerate development, they introduce external risks. Without proper management, outdated or vulnerable libraries can be pulled into builds, creating critical security loopholes or introducing compatibility issues that manifest unexpectedly in production. This constitutes a significant attack vector that often bypasses standard code reviews. A robust CI/CD pipeline must incorporate automated dependency scanning tools early in the integration process. These tools identify known vulnerabilities and transitive dependencies before they reach later stages. Beyond scanning, strict version pinning for all dependencies prevents unexpected updates from breaking builds or introducing new flaws. Utilizing private package registries can provide an additional layer of control, ensuring only vetted versions are available. Furthermore, generating a software bill of materials for each release offers transparency and simplifies incident response by detailing every component used. The fourth critical issue is environment drift, often leading to the works on my machine paradox. This phenomenon occurs when discrepancies accumulate between development, staging, and production environments. Configuration settings, installed packages, or even operating system versions diverge over time, making deployments unpredictable. A successful test in staging might fail catastrophically in production, not due to code errors, but environmental inconsistencies. This undermines the core CI/CD promise of reliable, repeatable deployments. To combat environment drift, infrastructure as code is indispensable. Tools like Terraform or Ansible define and provision environments declaratively, ensuring consistency across all stages. Containerization technologies, such as Docker, encapsulate applications and their dependencies, creating portable execution units that run identically regardless of the underlying host. Implementing immutable infrastructure, where environments are destroyed and rebuilt rather than updated in place, further guarantees consistency. This programmatic approach eliminates manual configuration errors and ensures that what passes in one environment will behave identically in another. The final, often neglected secret is the blind spot created by insufficient pipeline observability. Many teams lack real-time insights into the health, performance, and bottlenecks of their CI/CD pipelines. Without robust logging, metrics, and alerting, failures remain opaque, and performance degradations go unnoticed until they become critical. This absence of visibility transforms pipelines into black boxes, making effective troubleshooting and optimization extremely difficult. A well-instrumented pipeline collects metrics such as build duration, success rates, test coverage, and deployment frequency. Centralized logging aggregates output from all pipeline stages, facilitating rapid root cause analysis. Custom dashboards visualize these data points, providing an immediate overview of pipeline health. Proactive alerting, triggered by anomalies or threshold breaches, ensures teams are notified of issues before they impact delivery significantly. Embracing DORA metrics, deployment frequency, lead time for changes, mean time to recovery, and change failure rate, provides a data-driven approach to continuous improvement. These 5 secrets are not isolated challenges but interconnected facets of a mature CI/CD practice. Addressing flaky tests builds trust in automation, modularizing pipelines enhances agility, managing dependencies fortifies security, controlling environment drift ensures reliability, and gaining observability provides the critical feedback loop for continuous improvement. Neglecting any one area weakens the entire software delivery ecosystem. The path to elevating CI/CD mastery begins with a proactive shift in mindset. Instead of reacting to pipeline failures, teams must invest in preventative measures and continuous analysis. Regularly auditing pipeline configurations, integrating new scanning technologies, refactoring monolithic stages, and implementing comprehensive monitoring are iterative processes, not one-time tasks. This sustained effort transforms a basic automated workflow into a resilient, high-performance delivery engine. Unlocking the full potential of CI/CD demands moving beyond superficial automation. It requires deep engagement with these underlying complexities, systematically dismantling the hidden obstacles, and relentlessly optimizing every facet of the pipeline. Only then can organizations achieve truly reliable, efficient, and secure software delivery, fostering a culture of innovation and operational excellence.